25,000 miles of perfect highway. No wheels. No iron. No written plans. The Inca built the longest road network of the ancient world across the deadliest terrain on Earth, and they did it in less than a century. Modern engineers studied these roads for decades trying to understand how. And what they discovered. It wasn't just impressive. It was impossible. At least, it should have been. The Inca knew something we forgot. And by the end of this video, you'll know it too. Here's what makes this impossible. The Inca Empire stretched across 6 modern countries: Peru, Ecuador, Bolivia, Chile, Argentina, and Colombia. Their road network connected all of it. But the Andes Mountains have an average elevation of 13,000 feet. Temperatures swing from scorching desert heat to freezing blizzards within hours. The terrain includes active volcanoes, earthquake zones, and some of the deepest canyons on the planet. And the Inca built roads through all of it. Without the wheel. Without iron tools. Without draft animals strong enough to pull heavy loads. The Spanish conquistadors who conquered them wrote that these roads were superior to anything in Europe. Francisco Pizarro himself admitted he had never seen infrastructure this advanced. So here's the question that haunted archaeologists for 500 years: how? How did a civilization without our most basic tools build something we couldn't replicate today? Let's start with what they were working with. The Inca had no iron. They had bronze, but bronze is too soft for serious construction work. They had no horses, no oxen, no animals capable of pulling wheeled carts. In fact, here's something that will surprise you: the Inca knew about the wheel. They had wheeled toys for children. They simply chose not to use wheels for transportation. Why? Because wheels are useless in the Andes. Think about it. A wheeled cart needs flat roads. It needs gentle grades. It needs surfaces that won't destroy wheels within miles. The Andes offer none of that. The Inca looked at their terrain and made a decision that seems backwards to us but was actually genius. They optimized for feet, not wheels. Human feet. Llama feet. And this single decision changed everything about how they engineered their roads. If you're starting to see how different their thinking was from ours, hit that like button. Because what comes next is going to blow your mind. Now here's where it gets strange. Pause 2s, the Inca had no written language. No blueprints. No engineering manuals. Yet somehow, roads built by teams thousands of miles apart matched perfectly in design, grade, and construction quality. How do you coordinate that without writing? The answer is the Qhapaq, a system of knotted strings that could encode complex information through colors, knot positions, and string arrangements. For centuries, scholars assumed Qhapaq only recorded numbers. But recent research suggests something far more sophisticated. These weren't just accounting tools. They may have been a complete three-dimensional language capable of storing construction specifications, survey data, and engineering standards. Imagine carrying an entire engineering manual in a bundle of colored strings. Imagine standardizing construction across a continent without a single written word. The Inca didn't have our tools. They had better tools, tools we're only beginning to understand. Music shift, but the Qhapaq was just the communication system. The real engineering secrets were in the roads themselves. The Qhapaq Nan, the royal road, was the main artery of the entire system. It ran over 4,000 miles from modern-day Colombia to Chile. But calling it a road undersells what it actually was. In the coastal deserts, the road was marked by low walls to prevent sand from burying it. In the highlands, it transformed into wide stone causeways elevated above the surrounding terrain to handle seasonal flooding. In the steep mountain passes, it became staircases carved directly into living rock, sometimes climbing 3,000 feet in a single stretch. And here's what amazed modern engineers: the drainage. Every section of road had precisely calculated drainage systems. Water channels. Culverts. strategic grades that moved water away from the road surface. In a climate where a single rainstorm can wash away a modern highway, Inca roads built 500 years ago are still functional. Engineers from the University of Leeds studied these drainage systems and found they were more sophisticated than many modern road designs. The Inca didn't just build roads. They built roads that could survive anything. But that's not even the most impressive part. Pause 2s, imagine you're an Inca engineer. You need to cross a canyon. It's 300 feet deep. Maybe 500 feet wide. No cranes. No steel cables. No modern materials. What do? You build a bridge out of grass. I'm serious. The Inca invented suspension bridge technology using nothing but woven grass fibers. And these bridges could support entire armies. The secret was a grass called ichu that grows in the high Andes. When dried and woven correctly, ichu creates rope stronger than steel cables of the same weight. The Inca would weave massive cables, some as thick as a human body, and suspend them across impossible chasms. The most famous of these, the Qhapaq Bridge, has been rebuilt continuously for over 500 years using the exact same techniques. And here's what will really surprise you: if you're still watching, you need to subscribe for what's coming, because the Inca didn't just build bridges. They built an entire communication system faster than anything Europe had seen. The Chasca runners. Whisper, these were the human internet of the Inca Empire. Picture this: a message needs to travel from Cusco to Quito, over 1,500 miles of mountain terrain. In Europe, this would take weeks. The Chasca could do it in 5 days. Here's how it worked. Every 4 to 7 miles along the road network, there was a way station called a tambo. At each tambo, trained runners waited in shifts, 24 hours a day, 7 days a week. When a Chasca approached, the waiting runner would start running alongside him, receive the message, either verbal or encoded in Quipu, and continue at full sprint to the next station. They never stopped. The message never stopped. This relay system could move information at nearly 250 miles per day. When the Spanish arrived with their horses, they were shocked to discover that Inca messages traveled faster than their cavalry could ride. Think about that for a second. Pause 2s, runners on foot, in thin mountain air, at extreme altitude, outpaced horses. Drop your prediction in the comments: how do you think they moved actual objects along these roads? Now let me show you exactly how they engineered the impossible. The Inca road builders used a technique called fitting to terrain that modern engineers are now studying for sustainable road design. Instead of blasting through mountains or filling valleys, like we do, the Inca worked with the landscape. If a slope was too steep, they carved stairs. If the ground was swampy, they built elevated causeways. If bedrock was exposed, they used it as the road surface itself. But here's the engineering secret that took centuries to understand. Pause 2s, they built flexibility into their structures. Inca walls aren't held together by mortar. The precisely cut stones are dry-fitted with microscopic gaps that allow movement during earthquakes. The roads use the same principle. Instead of rigid construction that cracks under stress, Inca roads flex. They breathe. When a magnitude 8 earthquake struck Peru in 2007, ancient Inca walls survived while modern concrete buildings collapsed around them. 500 years old. Still standing. Still functional. Because they understood something we forgot: you don't fight nature. You work with it. And this brings us back to the question we started with. How did the Inca build 25,000 miles of perfect roads without wheels or iron tools? The answer isn't about what they lacked. It's about what they understood that we've forgotten. They understood that the best engineering doesn't fight the environment, it embraces it. They understood that communication and coordination matter more than raw materials. They understood that building for the long term means building flexibility into every structure. The Qhapaq Nan isn't just an archaeological wonder. It's a message from 500 years ago about sustainable engineering. And here's what's remarkable: when UNESCO made it a World Heritage Site in 2014, they noted that sections of the original road are still in use today by local communities. Still functional. Still serving their purpose. Half a millennium later, the Inca road system continues to work exactly as designed. But here's one final detail that changes everything. Pause 2's, the Inca achieved all of this in less than 100 years. The empire only existed from around 1438 to 1533. That's 95 years to build 25,000 miles of road, organize the labor of millions, and create an engineering system that would outlast the civilization itself by 5 centuries. In that same time frame, what have we built that will last 500 years? Most modern roads need complete replacement every 20 to 30 years. The Inca built infrastructure designed for eternity, and they did it in a single century. SFX, dramatic tone: the next time someone tells you ancient peoples were primitive, remember this: they built something we can't replicate. They solved problems we haven't solved. And their roads still work better than ours. The Inca engineers left us more than roads. They left us a blueprint for thinking differently about infrastructure. Modern civil engineers at universities around the world are now studying Inca construction techniques for answers to contemporary challenges. How do you build sustainable roads in earthquake zones? How do you create infrastructure that maintains itself? How do you engineer for centuries instead of decades? The answers are carved in stone across the Andes. And researchers are only beginning to decode them. The grass bridges. The flexible walls. The adaptive road designs. The human relay networks. Each element was part of an integrated system, a civilization-scale machine that connected millions of people across impossible terrain. We call them ancient. But maybe we should call them ahead of their time. So here's what you now know that most people don't. The Inca deliberately rejected the wheel because they understood their terrain better than we do. They built communication systems that moved faster than horses. They invented suspension bridge technology that wouldn't appear in Europe for centuries. And they engineered structures designed to last forever, and they actually did. The Qhapaq isn't just a road network. It's proof that technological progress isn't always linear. Sometimes the best solutions aren't the newest ones. Sometimes the ancient ways were better. And sometimes, the lost knowledge of a fallen empire holds exactly the answers we need today. 25,000 miles of evidence still waits in the Andes, teaching anyone willing to learn. If this video changed how you see ancient engineering, do me a favor, subscribe and hit that notification bell. We cover lost knowledge and forgotten innovations that mainstream history ignores. Now I want to hear from you. What other ancient engineering mysteries should we investigate next? Drop it in the comments. The best suggestions become future videos. And if you want to go deeper right now, check out our video on how the Egyptians really moved those massive stones. The answer isn't what you think. Thanks for watching. I'll see you in the next one.